the ground running. So 5.3, triangles and quadrilaterals. This is the last section that has a lot of terms. After this, sections 4, 5, 6 started to feel a lot easier to me. But some of these I'm sure are going to be review for you. But we're going to look at triangles and quadrilaterals. Triangles having how many sides?
3.
Awesome. And quadrilaterals having?
6. 7.
If you think of like a quad runner has 4 wheels. So triangles. So the first part is just triangles. Triangles always have 3 sides. That you probably don't have to write, or you're in real trouble if you do. The sum of the angles. Add up all the angles of a triangle. They should equal 180 degrees. So the sum of the angles. So if you add up the 3 angles in a triangle, it's going to be 180 degrees. Every time. So if you know 2 angles in a triangle, you could always find the third by doing 180 degrees minus those other 2 angles. Is we're going to find different ways to classify or group them. So different ways to classify. Have you guys done classification stuff in science?
Yeah.
Okay, so you kind of know what that's talking about. I'm going to throw a group in here, but if classify makes total sense to you, then skip it. But you have different ways to classify or to group them. And I'm going to switch over to, maybe I'll throw a letter A. I'll make it black to stick with the color scheme. First of all, classified by number of congruent sides. So by number of congruent sides. Congruent. What in the world does congruent mean in math class? Equal. Nice. So really it's kind of the number of equal sides. I'm going to say the first one then is going to be a scalene. So scale with an N-E at the end. So a scalene triangle is going to be, I'm just going to do a little triangle shape to represent triangle, but it's a triangle where all the sides have different lengths. Where all sides have different lengths. Another way to say that same thing would be to say there's no congruent sides. And I'm just going to draw an example. I'm just going to try to draw a triangle that has no 2 sides the same length. So something like that maybe.
But those 2 are the same, right?
Shouldn't be. That this one here should be the longest, and then this would be the next longest. It's kind of what I was aiming for, but. So that would be one. Next one. Can I flip pages on you? Anybody remember what's the name of the triangle that has 2 sides that are the same length? Maybe that's new. Number 2 then is isosceles. I-S-O-S-C-E-L-E-S. Isosceles. So this is a triangle with 2 congruent sides. With 2 congruent sides. Or in like normal person language, a triangle where 2 sides are the same length. If it has 2 congruent sides, you could also say, and 2 congruent angles. So if a triangle has the 2 congruent sides, then it has to have 2 congruent angles. And for my example of that, I'm going to try to make one. That looks fairly decent. I'm trying to have my upright sides, my left and my right side, be the same length. Are you guys used to doing like the little notation where they'd put like a little dash on any 2 sides that were congruent? Okay. That's something that you'll see later on, that they'll say like these 2 sides are equal or they're congruent, the same length. They'll put like a little dash. And then if you had like another pair of sides that were congruent but different, then they do like 2 dashes on the second one. But maybe I should just label it up then instead. So let me label it up. So we'll say A, B, and C. So I'm going to say side AB is congruent to AC. Does that look familiar? Because that's on the quiz that's coming up. Kind of saying segment AB and segment AC. Looking for some nods? Yes, we know it. We love it. Okay. Now the angles. What 2 angles are going to be the same? Or the angle that's noticeably different is, yeah, C and B is the same. So then you could say angle C is congruent to angle B. That if you have a isosceles triangle, the angle that one of the equal sides forms with a non-equal side is going to be congruent to the angle that the other equal side forms with a non-equal side. I probably should be saying congruent. But these two angles are going to always be the same in an isosceles triangle. And it would be possible, I wouldn't mess up your notes with this, but you could try to draw an isosceles triangle like this way too. And now it's not always those bottom two angles, but those two sides are congruent, so then this angle would be the same as that angle. Fair? So it could be oriented differently, but it's kind of the angle with the non-congruent side is congruent. All right. Then, so isosceles have two sides that are the same. Anybody remember the name? Have you ever heard the name of all three sides are equal? Equilateral. And nice. So equilateral. So EQUI lateral. So it kind of starts out with that word equal in the title. So this is going to be a triangle with three congruent sides. If all three sides are equal, how many angles do you think are going to be equal or congruent? Go for it, Jake. All three, nice. So you could say, and three, I'm going to leave a blank and then say angles. If all the angles are the same, what do all the angles have to be? If we jump back here, the sum of the angles is 180. 60, nice, because if you have 60 plus 60 plus 60 gives you 180, right? So very nice job, Jaden. So in three 60-degree angles. So not only are all three angles congruent, but all three angles have to be 60 degrees. And we'll see how my drawing is, but if you have an equilateral triangle, it might look something like that. And now you could say all three sides are congruent, so I'll do the little tick mark, a little hash mark on all three sides. And if you wanted to write it out, you could label it up and say A, B, C. You could say AB is congruent to BC is congruent to AC. And you could say angle A is congruent to angle B, which is congruent to angle C, and they all have to equal 60 degrees. So you could write it out that way. But that's one way that we could classify triangles, by number of sides that are congruent. So you have your scalene, none of the sides are congruent, no sides are equal to another side. Isosceles, two sides are equal. Equilateral, all three. Questions up to there? Fire. Yeah, so I should have put a line over the AC as well. Right. Second way to classify triangles. So we could do it by sides, but the second way is going to be by angles. So classified by angle measure. So our letter A was classifying and putting them into groups based on their number of their side lengths. Now we're looking at their angles. So the first one is going to be acute. I think we talked about acute angles earlier this chapter. Acute angle is going to be an angle that's less than 90. Nice. So now if we have an acute triangle, a wise person would guess all the angles are? Yep, all the angles are less than 90. So it's going to be all acute angles. And by that we mean it has to be less than 90 degrees. So less than 90 degrees. In an example, my guess is when you think of a triangle, you probably think of an acute triangle. So an equilaterals would be acute, an isosceles would be acute, but normal triangles are probably going to be acute angles, or an acute triangle, at least if your brain works like mine. The second type then is going to be a right triangle. And a right triangle then has to have one angle that's That's a right angle. It's 90 degrees. So good. So right triangle has one right, or I'll throw in parentheses, 90-degree angle. And so your right triangle is going to be something like that there. And the key is you have to have one angle that's 90 degrees. You okay on the right triangles? Oh, go for it. Yeah, your right angle could be differently shaped, so this might not be what you were talking about, but could have something like that there. Just have to have somewhere one of the angles has to be 90 degrees. So our third type this way is going to be obtuse. And obtuse angles are greater than 90, so this has to have one obtuse. And by that we'll say greater than 90-degree angle. And so when you draw yours, you just need to make sure that you have one angle that's greater than 90. How come we can't have two angles greater than 90? Because, it's impossible because, do you want to take it, Xavier?
Because.
So you couldn't have two angles that are more than 90 or you'd already be over 180 degrees, and that's the total number of degrees in a triangle. That is true. You need more than three sides to connect it. That'd be a good way to put it. All right, then the second half of the notes are going to be our quadrilaterals, which we said are four-sided figures. So quadrilaterals. So quadrilaterals. All quadrilaterals are going to be four sides. So they're a four-sided figure. And now, we were just talking about how the sum of an angle, you couldn't have a total number of angles being 180 and have two angles that are bigger than 90 and connected. So if you have four sides, total angle is going to be not 180, but... Be right to you.
I have a question.
Be right to you. Go for it. Any guesses? Somebody shout it out.
Wait, what's the question?
If you added up all the angles in a four-sided figure, think of a square.
200.
360 degrees.
Who said that?
Because if you think of a square, you have four angles that are all 90, 90 plus 90 plus 90 plus 90, 360. Well, maybe do this. So quadrilateral. I want to talk about one of the kinds we're going to talk about next, and I'll maybe throw it in red. Oops, it's supposed to be in red. So, name of the first kind of quadrilateral I want to look at is a trapezoid. So trapezoid. So trapezoid. A trapezoid is going to have four sides, but what separates it from rectangle or a square or parallelogram, these other things we're going to look at, is only one pair of sides is parallel. So only one pair of sides is parallel. And so I'm going to make it where my top and my bottom side are parallel. That's usually how it's done. That you have to have two sides that are parallel. Then the other pair of sides is not. So something like that. Usually when people draw trapezoids, it'll look something like that. You could have done, something like this here as well. But those would be like examples of trapezoids. That you have to have two sides that are parallel and then two sides that are not. We okay on trapezoids? The next side that we're going to look at, or the next type that we're going to look at, is going to be where you have two pairs of parallel sides. And that would be a parallelogram. So let me turn the page in my notes. I'm going to try to set mine up. I don't know if you can kind of look at my page, kind of like a pyramid of sorts. So I'm going to put parallelogram right in the middle of the page. Then I'm going to branch off into kind of a group on the left and a group on the right. This is my second way of doing my notes. I totally started over this section. So I thought this would make the most sense. So my first one is going to be a parallelogram. So a parallelogram. And with that, I'm going to say two things. Opposite sides are two things. One, parallel. And the second is going to be opposite sides are congruent. Or equal, or you could say if you wanted to, the same length. So for our parallelogram, an example of it would be something like this here. Actually, I'm going to take and make those a little bit more on an angle. It doesn't look amazing, but this side here should be congruent to that side, and this side here should be congruent to that side. So the ones that have like the one little tick mark are equal in length to each other. The two sides that have the two little tick marks are equal in length to each other. We okay on those? Now we can break our parallelograms up into a couple different classifications. So I'm going to go left, I'm going to go right. On the left side, I'm going to say these are going to be the ones that have 90-degree angles. On the right, these are the ones that have not 90-degree angles. So if we have a parallelogram, we have something that opposite sides are parallel and they're equal in length. We could break them up into a rectangle. That rectangles fit that same thing. So rectangles, they're special parallelograms. So special parallelograms, and for them, they're special in that they have 4 90-degree angles. And so if I try to draw in my rectangle, so it still fits that requirement of a parallelogram, that opposite sides are congruent, that my top and bottom are the same length, my left and right, they're the same length. But now we could add in there as well that this angle's 90, this angle's 90, this angle's 90, that angle's 90. We okay on rectangles? Now I have one more that I want to throw over here on the left side below my rectangle. What's a special type of rectangle? Square. That a square is a special type of rectangle in that a square fits everything that this rectangle says, but not just two pairs of sides are congruent, but all the sides are congruent to each other. So the top and bottom are the same length, the left and right are the same length, but top and bottom and left and right are all the same length. So a square then is going to be, it's a type of rectangle or maybe a special rectangle. Are all rectangles squares? I probably should finish the definition of a square before asking that, but keep that in mind. All 4 sides are congruent. So then my example, so I have 4 sides that are all congruent. I have 4 angles that all must be 90 degrees. So a square is a type of rectangle. Is a rectangle a type of square? Abby?
No, because not all 4 sides are congruent.
Perfect. So in order for it to be a square, all 4 sides have to be congruent, that right there. And rectangles don't have to fit that. So good. Very nice. I like how you think. Okay, did everybody get the square stuff down? We're close. One more to go and then we're done. Last one then, a rhombus. So rhombus. R-H-O-M-B-U-S. Rhombus. So a rhombus is going to be a special parallelogram where a rhombus is kind of to a parallelogram what a square is to a rectangle. That a square, all 4 sides have to be the same length. All 4 sides are congruent.
Sister and a brother-in-law. They're not exactly related, but they kind of are.
But they are. Sure, you could call that sister-in-law and brother-in-law. So special parallelogram. So it's a special parallelogram. And the key is all four sides are congruent. So all four sides are congruent. Trying to squeeze it in there. So in other words, before our parallelogram looked like that. We want to do that same figure as what we have up at the top, except we need to make all four sides the same length. So it's kind of like a square that's been squished sideways. So maybe something like that. So do that to show that all four sides are the same length. That's it for the notes. Does it make sense? Any questions? Before you just randomly